So yeah, hello everyone, welcome back to our daily LeetCode challenge series. So today is day 86 and today we are going to solve LeetCode problem 169 majority element. Okay, so this is an easy level problem, so let's see the problem statement first. So we have given an array nums of size n, return the majority element. The majority element is the element that appears more than n by 2 times. Okay, so you may assume that the majority elements always exist in the array. Fine. So we have given one example, the array of num is 3 2 3, and here we can see 3 occurs twice and 2 occurs once, and we have to find a majority element which means like n by 2. So n, here we can say n is the length of the given array, right? So n by 2 will be more than 1, so more than 1 is 3, so that's why we're returning output 3. Okay, similar example 2, we can see the total elements in the given array is 7, so majority elements should be like if we do 7 by 2, then it should be more than 3, right? So we can see like 2 occurs 4 times here and 3 occurs 3 times only. So 1 is not a majority element, 4 is the majority element because it occurs more than like n by 2 times. That's how we return 2. Fine. So in the constraint we have given like as I've said, like n is equal to the array of the length, right? N value can be vary from 1 to 5 into 10 to the power 4, that's within the integer range, and even num of I is also like minus 10 to the power 9 to 10 to the power 9. Fine. Okay, so the input is generated such that the majority element will exist in the array. So this is for sure, like majority element will always be there in the given problem, right? So the follow-up we have given, could you solve the problem in the linear time and in 0 1 space? Okay, so as this is a zero problem, so we can directly count the frequency and get the value element which is greater than n by 2, but that will take extra space. Like if we use the even frequency array, it will take big of n, right? If we use HashMap in order to take the frequency, it will also take big of n space for storing the frequencies. But we need to solve this problem within a big of 1 space. Okay, so what we can do in this case, like maybe you are aware of that Boyer-Muri voting algorithm. Okay, so basically that algorithm says, so it's basically like a voting system. So whenever one new candidate comes up, we will assign it as a winner in the initial stage for their one vote. If some other candidate will come with other vote, then we will minus the voting part. So whatever left at the last, that will be the winner candidate, right? So let's start the solution part. I will explain you. Okay, so here we have given the majority element nums. So what we'll do, first we'll create one integer candidate, let's say 0, and let's say vote equals to 0 for now. Okay, 0 votes. Now we will iterate over the given array. So let's say int n equals to 1 nums. Fine. Now that algorithm says, like voting algorithm says, if we have the voting is 0 currently, so if vote is 0, that means whatever the candidate is coming first, that will be the winner. So we are assuming like the initial stage, initial vote will always be 0, right? So we will, whatever candidate is coming, so here n is the candidate that is coming, so that is the winner. Okay, we will assign it as candidate equals to n here, right? And we will like we have to also update the vote. So we will increase the vote by 1 if the current candidate and like the vote we are getting, it is equal, right? So our current candidate is n, and it is equal to candidate, that means we have got a vote for this candidate only, right? In that case, what we'll do, we'll increase by 1. Otherwise, if it is not so, if some other candidate is coming in order to vote, then we'll decrease the voting count. So this is how we're going to update. So at last we will got the exact candidate even if so let's come to the example one. Let's say we have got 3. Okay, we have assigned candidate 3 as a winner. Okay, and we'll increase the vote by 1 because candidate and the current vote we are getting is of 3, so we are increasing by 1. Second, we are getting 2, so 2 is not our vote is not here, right here, but even here it is false because the current candidate is 3 that we have assigned, but current voter we are getting is 2, so which is not same, so it will minus the vote, so now vote will become 0. Previously it was 1 and now it will become 0. Now again in next iteration it will come to 3. 3 is our candidate, vote is 0, so we are again assigning a winner as 3, right? That's how it will work. Okay, and we are using no extra spaces here, just some like constant space for to store the candidate and the vote count. Now at last we'll simply return candidate. Okay, once all iteration is done. Fine. Now let's submit and see the test cases. Okay, fine. I've given the spaces. My bad. Okay, so we can see like we have got passed both test cases. Now submit and see other test cases as well. Okay. So yeah, you can see it passed all 53 test cases and beats 99.85%. That's quite good enough. And as per the expected, we are using just big of 1 space in our solution, and time possibility anyways we are iterating over each of the elements in the given array, so it is big of n. So yeah, if you know any other approach other than this algorithm like Boyer-Moore's voting algorithm, then you can just comment it down to any possibility to do with big of 1 space regardless of using this algorithm, right? So that's all for today. Let's see you next video. Bye.